Okay, so we're going to do chapter 5 next, and we're going to start with 5.1. So chapter 5 is properties of geometric figures. So we're looking at triangles again, but not just triangles, so other geometric figures as well. The nice thing about this is it starts with right triangles, which you guys already know how to do, so this should be fairly easy to start with. Okay, so this first little bit is just review. It says in this section, you'll need to use the Pythagorean theorem and the trigonometric ratios when working with right triangles. The Pythagorean theorem states that for any right triangle, a squared plus b squared equals c squared, where a and b are legs of the triangle and c is the hypotenuse. So again, when we look at a right triangle, that right angle, if we turn it into an arrow, it always points at the c side, or we can also call this side the hypotenuse. When we're looking at this, the trigonometric ratios go back to those easy ones, those original ones of SOHCAHTOA. Okay, trigonometric ratios aren't the sine and cosine law. If you didn't like the sine and cosine law, you don't actually have to use these for this stuff because we're talking specifically about right triangles. Right triangles, we can always go back to the trigonometric ratios, the SOHCAHTOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So we're not worrying about the sine law, the cosine law anymore. You can actually use those for right triangles, but they're more work, so don't worry about it. Okay, so again, those primary trigonometric ratios are the sine, cosine, and tangent. They're calculated as follows. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. These ratios can be used to calculate the missing angles or side lengths of right triangles. Okay, so if you look at a question you're given and it gives you two sides and it wants you to find the third side, as long as it's a right triangle, we can use Pythagorean theorem to do this. So the side straight across from the right angle is always side C in your formula. A and B don't matter. So if we're using our Pythagorean theorem, we got the a squared plus b squared equals c squared. They've written it with the different letters because they've labeled their triangle differently, but that hypotenuse is always the one that's by itself. So the 7.6 squared plus the 9.4 squared equals the a squared, or the c side squared. Add them together. The final step is take the square root of both sides. That causes your square root and your squared to cancel out, leaves you just with the side you're looking for. Okay, so now it specifically says use the Pythagorean theorem to find the missing side length. So when I look at this, I've got a right triangle, which is good. Right angle always points at my C side in my formula. It specifically says use the Pythagorean theorem, so I'm going to do it. I'm going to do a squared plus b squared equals c squared. Doesn't matter which sides I call a and b, the only important one is c. So my a squared, I'm going to do the 69.3 squared plus the 47.6 squared equals c squared. I typically rewrite it with the c squared on this side, but it doesn't really matter. So 69.3 squared is 4802.5. 47.6 squared gives you 2265.8. Add them together and c squared is going to equal 7068.3. We're not solving for c squared, we're solving for c, so we take the square root of both sides, making that cancel. And c, in this case, which is side y, is going to be 84.1. And we had centimeters in our original, we've got centimeters in our answer. Okay, so again, like always, pause the video as you go, stop and make sure these things are going into your calculator right. If you can't figure out how to put them in your calculator or you're getting wrong answers, double check with me next time you're in school. Okay, again, we've got a right triangle. We've got two sides. We're missing the third, so we're going to use a squared plus b squared equals c squared. The right angle points at the c side in my formula, which means in this case I'm solving for a. It starts the same way though. A squared plus b squared equals c squared, which means a squared plus 125 squared. Oh, sorry, that has to be our hypotenuse, our c side. So the 98 squared equals 125 squared. Okay, they called A, so I'm going to leave it like that in my formula. So a squared, I can rearrange this because I need my a squared by itself. So I'm going to do the opposite to what's happening. So it's a squared plus 98 squared. I'm going to subtract 98 squared on both sides. That lets this cancel out and my a squared is left by itself. So now on the other side, I've got 125 squared minus 98 squared. So my a squared is going to be 15,625 minus 9,604. If I do that in my calculator, I get a squared is equal to 6021. Last step is to take the square root of both sides. So my a side is 77.6. And I have millimeters in my question, millimeters in my answer. This one is two triangles stuck together, so I'm going to try and use what I know to find enough information. When I look at side P that I'm looking for is part of this triangle. And in that triangle, I don't know the length of any of the angles except for that 90 degrees, and I only know one side. So right now, I don't have enough information to solve for P. What I do have is this other triangle that's also a right triangle, where I know two of the sides. If I use this triangle first, I can solve for this side, and then I can use that information to solve for side P. So I'm just going to redraw that part of the triangle. This is 68.4 centimeters, 89.5 centimeters. This is the side I don't know right now. So my right angle points at my C side in my formula, which means this is, I'm going to call it A. So using my formula, a squared plus b squared equals c squared. So x squared plus 68.4 squared equals 89.5 squared. Again, I want to rearrange to get the x squared by itself, so I'm going to subtract the 68.4 squared from both sides. Then the plus and the minus cancel out. So x squared equals 89.5 squared minus 68.4 squared. So x squared equals 8010.1 minus 4678.6. So when I simplify, I get x squared equals 3331.5. And take the square root of both sides so that the squared and the square root cancel. I get that this side length is 57.7 centimeters because I had centimeters in my original. That's not the answer. This is now this piece right here, 57.7. And that helps me because now I can use my other triangle to actually solve for P. So my other triangle looks kind of like that. Those are the two sides I know. My right angle points at my c side in my formula. So this time I'm going to do a squared plus b squared equals c squared. But I'm solving for the c part, so I'm just going to leave it written as is. So 57.7 squared plus 46.9 squared equals p squared. So p squared equals 3329.29 plus 2199.61, or p squared equals 5528.9. Square root of both sides is my last step. So p equals 74.4 centimeters. That's my final answer. Okay, so that's using Pythagorean theorem. The next piece is how to use SOHCAHTOA, which again should be super easy. You guys have done lots of this already. So the hardest part with SOHCAHTOA is how to assign your sides. Across from our right angle is always the hypotenuse. Straight across from the angle we know is always the opposite side, which makes your third side your adjacent. This triangle over here, we're talking about finding the measure of angle E, which means our unknown angle is right there. Our right angle points at the hypotenuse. The angle we're trying to find across from it is always the opposite, which makes our third side the adjacent. In this first triangle, we know something about the adjacent. We're trying to find the hypotenuse, which means we're going to use a formula that has adjacent and hypotenuse in it. Adjacent and hypotenuse is the cos formula, which is what they do below. The second triangle, we know something about the hypotenuse. We know something about the opposite, which means we need opposite hypotenuse in our formula. That's going to be the sine function. As you look at their example, they make it look more complicated. When you get yours to right here, you're going to remember the trick. Cos of 41 degrees equals 4.2 divided by W. Whenever the thing we're solving for is on the bottom, we switch everything top and bottom. So the W comes up here. The entire cos 41 goes on the bottom. It gets you this part is the same as right here. It just skips all of those middle steps. Makes your life a little bit easier. So anytime the thing you're trying to solve for is on the bottom, you just want to switch anything on the left with anything on the bottom. And then when you're solving for an angle, don't forget that when you're getting to this point right here, to get rid of the sine function, you have to do the opposite. So that's that inverse sine on both sides. That causes the sine and the inverse sine to cancel out, leaves you with this. And on your calculator to do the inverse sine, you're doing the second sine, and that gives you that sine -1 option. Okay, so we're going to solve for the side lengths, or we're going to solve for the angles using our SOHCAHTOA only because we have right triangles for all of these. Okay, in this case, right angle points to the hypotenuse. Our angle points to the opposite side, makes our third side the adjacent. We want hypotenuse and we want opposite in our formula. That's going to be our sine formula. Fill in what we know. So we know our angle is 27 degrees. Opposite we're calling x. Hypotenuse we're calling 2.8. And then when the thing we're solving for is on the top, we have to, it's being divided by a number. We're going to multiply by that number so that it cancels. So x is going to be 2.8 times sine of 27, which which means in this case, x is going to be 1.3 centimeters. Centimeters because we had centimeters in our original question. Okay, the next one, start by assigning our sides. Right angle points at the hypotenuse. Our angle that we know points to the opposite side, which makes the third one the adjacent. In this case, we know a number for the opposite. We're trying to find the adjacent, so our formula has to have those two in it. That's going to be the tan formula. Fill in what we know. So we know our angle is 41 degrees. We know our opposite side is 20.2. Our adjacent side is the x we're solving for. X on the bottom, so we swap. X equals 20.2 divided by tan of 41. When we type that in our calculator, we should get x equals 23.2 millimeters in the question, millimeters in the answer. We've got a right triangle, starts the same way, assign our sides. So right angle points to the hypotenuse, angle we know points at the opposite, makes our third one the adjacent. In this case, we're talking about hypotenuse and we're talking about adjacent, which makes our formula the cos formula. Fill in what we know, so 62 degrees, adjacent is 3.3, hypotenuse is our x. X on the bottom, so we swap. X equals 3.3 divided by cos of 62, which means our x equals 7.0 centimeters in the question, centimeters in the answer. When we're solving for an angle, it works the same way. The only difference is we're not solving for a side length anymore. We have to use that second sine function, or second cos, second tan, in order to get our angle by itself. It still starts out exactly the same way. The right angle points at our hypotenuse. Then you got to figure out which angle they're actually looking for. It says the measure of angle A, which is down here, which means this one straight across from it is going to be our opposite. Our third one is our adjacent. In this case, we know something about the opposite, we know something about the adjacent. We need those two things in our formula. Opposite and adjacent is tan. We don't know our angle anymore, so we have to leave it as the angle symbol, or we could call it capital A because we're looking for angle A. We do know our opposite side is 5.1. We do know our adjacent side is 8.3. So now, to get the angle by itself, we need to do the inverse. So in this case, the inverse tan, so that the tan and the inverse tan cancel, need just the angle symbol by itself. What that means is, on the opposite side, we got tan negative 1 of 5.1 divided by 8.3. And in this case, our angle is going to be 32 degrees. Okay, so second tan on your calculator, 5.1 divided by 8.3. Last one for this page, our right angle points to the hypotenuse. It still wants us to find measure of angle A, so this angle over here, that one points to the opposite side, which makes our third one the adjacent. We need a formula of height and op. O and H is the sine formula. So sine of our angle is the opposite, so 17.3 over the hypotenuse, so so 25.8. We need to do the inverse sine to get our angle by itself. If we do it to one side, we have to do it to the other. So our angle is equal to the inverse sine of 17.3 divided by 25.8, which means our angle is equal to 42 degrees. Okay, last one for this. Our right angle points at the hypotenuse. We're solving for angle A, so over here, across from the angle is always the opposite, which makes the third one the adjacent. In this case, we want hypotenuse and we want adjacent in our formula. Adjacent and hypotenuse is cos. So cos of our angle equals the adjacent, or 80.4, divided by the hypotenuse, which is 129.5. Inverse cos to get the angle by itself. So our angle equals cos negative 1, or inverse cos of 80.4 divided by 129.5. When you put this in your calculator, you should get 52 degrees. Okay, so that's it. That's the review of sine, cos, and tan, as well as Pythagorean theorem. The rest of this is new stuff for this year, but not necessarily new to you. Some of this is hopefully familiar. Okay, so your new skills is working with properties of triangles. So a property is a characteristic that classifies the object and distinguishes it among other types of, or objects of its type. So what properties describe a triangle? All triangles have three sides. All of them are a closed figure, and when you add up the interior angles, they add up to 180 degrees. That's true for all triangles. We can further classify triangles, though, based on their side lengths or by the sizes of their interior angles. So if we're talking about their angles, there's three different types of triangles. There's an acute triangle, where all three angles are less than 90 degrees. There's a right triangle where it has one 90-degree angle. And there's an obtuse triangle where one angle measure is greater than 90 degrees. You need to know these, and you need to know how to draw them and to remember which is which. The way I was kind of taught to do it is that acute, the word sounds like cute. So these are the small little angles, or the small cute angles. Okay, the small cute angles are all less than 90 degrees. If you added all three up, they still add up to 180, but none of them is bigger than 90. None of them is equal to 90. They're all the little tiny cute angles. A right angle, you should know, you should recognize that that right angle triangle always has that right angle symbol in it. And then for me, obtuse sounds like obese. So these are the big fat angles. Okay, so those obtuse, obese, fat angles is the one that's greater than 90 degrees. So in this diagram, this would be this angle right here. It's a big angle, it's obtuse, it's obese, it's bigger than 90 degrees. I don't care how you remember these, but you do have to remember them. You have to know the difference. Okay, so that's classifying triangles by their angle measurements. We can also classify them by the lengths of their sides. Okay, and again, you need to know this. So an equilateral triangle is that three sides are of equal length, and all three of your angles are then equal as well. So in equilateral triangle, everything is equal. We show that the side lengths are equal by using those little hash lines. What that means is every line that has that little hash line on it is the exact same size. So in this case, because we're talking about all the angles being equal, there's 180 degrees in a triangle divided by 3 equal angles means that each one of those angles is 60 degrees. So this right here is 60 degrees, this one's 60 degrees, that one's also 60 degrees. Okay, but equilateral triangle has the word equal in it. They're equal lengths. All 3 sides equal lengths. An isosceles triangle is when 2 sides are of equal length and 2 of the angles are equal measure. So equilateral is all 3 equal. Isosceles, there's 2 that are equal. So in this diagram, the tall 2 are the same size. There's always 2 sides that are equal as well as 2 angles that are equal. And the 2 angles that are equal are always the 2 that are at the bottom of the equal sides. So whatever this side angle is, it's equal to this angle over here. Okay, and then a scalene triangle is anytime all 3 of your sides are of different lengths. And what that means is that also all 3 of your angles are different as well. Okay, so they're going to do a lot of kind of real world examples for this, but you need to know how to classify triangles by angles. You also need to know how to classify them by side length. That's a given. That absolutely has to happen. So know those 2 charts. Okay, so the next one is kind of how they start to use these things. It says use the following diagram to answer the questions below. So what is the length of side BC? And then classify triangle ABC by angle measure and by side length. So first of all, side BC is the side from B all the way across to C. And side BC is part of the big outside triangle. But if we don't have enough information to use it as a big outside triangle, we can also look at the triangle properties. I can tell that this side and this side are equal lengths. What that means is, because I know this now is an isosceles triangle, the angles at the bottom are equal size as well. So if this side right here is 53, that side over there is also 53. And if side B is 20 centimeters, side C is also 20 centimeters. So this maybe doesn't look like it helps me, but it actually does. I know my 2 side lengths, and I now know this angle as well. Because this angle is going to be 180 degrees minus 53 minus 53. So this is going to be 74 degrees. Now I've got some options. I can use my big triangle, and I can use my sine or cosine law to find side BC. Or if I don't like my sine and cosine law, I can think of this as 2 little triangles, where this side is x, this is 16, this is 20, this is 53 degrees. And I can use my Pythagorean theorem and or my sine, cos, and tan to find this side. And if I find that half, this half over here is also the same. So if I double it, I'll have my total length from B to C. So that's what they're going to do in the next example. But before we do that, we're going to classify triangle ABC by angle measure and by side length. So when I look at it by angle measure, this is either an acute triangle, a right triangle, or an obtuse triangle. I know all three of my angles now. I've got 53, 53, 74. They're all less than 90 degrees, which means for my angle measure, this is going to be an acute triangle. They're all cute and little, they're all less than 90 degrees. When I'm going to measure it by, or classify it by side lengths, I have two sides that are the same length, which means two sides the same, two angles the same. This is an isosceles triangle. So we would classify triangle ABC as an acute isosceles triangle. Okay, on the next page, it's just going to show you how they went about solving this. So they chose to divide it into two right triangles, and they used Pythagorean theorem to calculate the length of side DC, so that bottom one, which they found to be 12 centimeters. Then, because that's half of the big triangle, or half of between B and C, they times it by 2, got 24 centimeters in the end. Okay, so there's a few different ways you can solve these a lot of the time. They're not always one way to do it. It depends on what you see first. It depends on what you like. It depends on which formulas you like to use. If you're open to any formula, your life will be way easier. If there's only a certain few you like, it's going to take a little bit more work to try and figure these out. Okay, this one note says, use the following diagram to answer the questions below. What's the measure of angle M? Okay, we're not given a lot of information in this question. But I do see that this side and this side are equal lengths, which means if the right side is 15 meters, this other side is also 15 meters. This would be an isosceles triangle. Because it's an isosceles triangle, the angle at the bottom of the sides, they're equal as well. So I know if one side is 60, the other side is also 60. I'm looking for the angle of, or the measure of angle M, which is this top angle. Now I know two of the angles in my triangle. I can find the third one by doing 180 degrees minus the two angles I know. So 180 minus 60 is also 60 degrees. And because all of my angles are the same, that the only way that can happen is if all three of my sides are the same. It's the only way it's possible to get three angles that are the same. So the measure of angle M equals 60 degrees. And now if I classify triangle NP by angle measure and by side length, according to my angles, it's 60 degrees, 60 degrees, 60 degrees. They're all equal. This is an equilateral triangle. Oh, sorry, that's the one for the side length. Equilateral is a measure of side length. For angle measure, I'm looking at how big those angles are. All three of them are 60 degrees, which means they're small. This is going to be an acute triangle. Okay, so it would be an acute equilateral triangle. This next one says, what's the length of side PR? So side PR is the side all the way across this piece of the triangle. In this case, I know that this side that's 8 meters is equal to this side that's also 8 meters. And if I look at my triangle, this big outside triangle is a right triangle. So if I just redraw that piece, this is the side I want to know. This is a right angle with 8 meters here and 8 meters here. Since it's a big right triangle, I can use Pythagorean theorem. This is going to be my C side. So a squared plus b squared equals c squared. So 8 squared plus 8 squared equals x squared. X squared equals 64 plus 64. So x squared equals 128. Last step is take your square roots. So the square root and the square roots cancel. Square root of 128 is approximately 11.3 meters in the question, meters in the answer. So the length of PR is 11.3 meters. Next piece says classify triangle PQR by angle measure and by side length. So PQR is this big one along the outside. PQR has two sides that are the same and one side that's different. So for our side length, that makes this an isosceles triangle. When I look at my angle measures, I have a 90-degree angle in there. That's what that little square means. 90-degree angle means it's a right triangle. Okay, so triangle PQR would be a right isosceles triangle. The next part says classify triangle QRS by its side length. I'm just going to redraw what QRS actually looks like. So if I go back to my original drawing, Q was over here, S was here, this was R, and actually I'm going to flip back to it for a second, because here, if this side is a right angle, this side is also a right angle. So angle S is a right angle on either side of that, which means in the one I'm drawing right now, this right here is a right angle. I also know that this is 8 meters. And I know that that whole side, so when we had our big one of PQR, that big right triangle, this side was 11.3. And because this is split exactly in half, the half that's at the bottom, this side right here is going to be 11.3 divided by 2 because it's half of the big side we had before, which makes it 5.65 meters. In order to figure out how big this side is, I have to figure it out to classify by side length. So I need to work that out before I can figure out if it's equal to one of the other two. I know for sure this isn't an equilateral triangle because I've got two sides that are different already. But if that third one is the same as one of those two, it makes it an isosceles. If it's not, it makes it a scalene. So again, I've got a little right triangle, and I can use my right triangle formulas because straight across from my right angle is C, which makes this A in my formula. So a squared plus b squared equals c squared. So I've got x squared plus 5.65 squared equals 8 squared. I'm going to subtract the 5.65 squared on both sides. Makes that cancel. X squared equals 8 squared minus 5.65 squared, which means x squared equals 64 minus 31.9. So x squared equals 32.1. And when I take the square root of both sides, my x equals 5.66. This is actually meant to be 5.65. They should be exactly the same based on all the other angles in the question. It's just that we rounded a little bit and we worked with a rounded answer, so now our answer is not quite exactly the same. But it's close enough, we'll call it the same as the 5.65, which means we've got two sides that are the same and one that's different. If we classify this by side length now, we're talking about an isosceles triangle. Okay. Question 6 says, an equilateral triangle XYZ has a perimeter of 90 centimeters. What is its area? If you don't remember it, the area formula is off to the side. Area equals the base times the height divided by 2, or area equals 1/2 base times height. So if you like it this way, exact same thing. So when I look at my triangle looks like this. This part down here is my base. This is my height. And I don't have a number for the height yet, which means I need to find it. As soon as I see that these two sides are equal, I know that this is exactly halfway. That's one of the properties of an isosceles triangle, which means of this 30 centimeters all the way across the bottom, 15 centimeters on this side, and 15 centimeters on that side. So I can use my little right triangle to find the height, because I know the outside piece is 30, and this bottom is 15. Okay, so my right angle points at my C side, which makes this A and B. A squared plus B squared equals C squared. So H squared plus 15 squared equals 30 squared. Rearranged by subtracting the 15 squared. H squared equals 30 squared minus 15 squared. So H squared equals 900 minus 225. H squared equals 675. Square root of both sides, so cancels. H equals 26 centimeters. Okay, that gives me my height. I need to go back to the whole big triangle though to find my area. So area equals base times height divided by 2. So my base is all the way across the 30 centimeters. My height, I won't put it in brackets. My height is 26 centimeters. That's what I just solved for. And I'm going to divide it by 2. So I'm going to do 30 times 26 divided by 2, which is going to give me 390 centimeters. But this was centimeters right here, and this was centimeters right here. So centimeters times centimeters gives me an area of centimeters squared. I need that squared on my units. It doesn't mean square my number again, do 390 squared. It just means my units are now units of area. An area is always a number or a unit squared. Okay, about 5 more pages. I'm going to stop here. I'm going to start a new recording because I don't want it to get too long because it seems to get glitchier the longer it gets. So this is part 1. I'll start part 2 in a sec.